Hello once again. This is Charo Links, the same project of stock price prediction, and the authors of this project Smasimenta Cynthia and Charo Links, and it's being presented by Charo Links. So in this project, as you well know, the stock market is an important sector in the business world. For it keeps updating the trader. It is based on the demand and supply factors. It depends on trends, news, and patterns of production. It is always very difficult to do accurate predictions, though they are very helpful to traders since they enable them to make profits. So most traders do the predictions manually, for example, using charts, price indices, news, but it's difficult work, as you all know. You can prove that. However, this can be made easy by the use of the big data set, which can be got from any sources. Machine learning techniques are used to make very accurate predictions. So the machine learning algorithms that are used are long short-term memory and regression, which make the prediction more accurate. Considering regression and long short-term memory by building the model, where regression is used to minimize the error rate and long short-term memory is used to remember that the data and their dependencies for a long period of time. In this project, we are using numeric as the data type. So the background of this project and what motivated us to do this project. As you all know, predicting prices is one of the challenging tasks in the trading sector by most companies. The traditional predicting prices by estimation mainly is not sufficient enough to give correct results and discount errors. So using this model, it is easy to monitor the activities and capture all the possible factors, considering factors of demand and supply while using the data of a given period. This also promotes accountability since the records are always kept and ensures proper functioning throughout the life cycle of this artificial intelligence model. Then, while carrying out this project, we had weaknesses. You can call them disadvantages of using the supervised and unsupervised learning techniques. Where supervised learning technique, in this technique, you can be given labeled data and the output, so you use it to train the model and gives you the output. While in unsupervised learning, you don't the given data is not labeled, so it's up to the model to learn, label it on its own. So due to unlabeled data, there is limited accuracy in unsupervised learning. So unsupervised learning often have limited accuracy as they do not have the labeled data and have to identify the data themselves to train the model, and thus do not give the best results. Then we face the AI technical challenges facing the existing techniques include the bias problem. The bias problem for it, the arbitrary of a stack with which an algorithm is to be applied. So this is problematic as stock selection is not arbitrary the process. Overwhelming data. So we also have that problem. This is where the data is too much that the AI design cannot handle. For example, when there is a lot of stock to be predicted than the expected number. Then lack of skilled manpower. This is one of the biggest challenges in AI as most people have no skill of using the models. Then we have what we contributed to this, what this term paper contributed to this project. So these refer to the solutions of the technical challenges we faced up. Therefore, you use minimal data, where the data fed to the model should be minimum enough for it to handle in order to produce the expected results. And also, because the users do not have the skills to use the models provided, so you train the users. Then we have the methodology. This refers to the process, what you used, how this model was trained. So the proposed methodology is based on machine learning algorithms such as regression and long short-term memory network, where regression is a supervised learning algorithm with a continuous and constant slope expected performance, which is used to estimate values with a continuous range rather than attempting to classify values into groups. So data which includes market prices, quantity of the different stock for a given period of time from the users to be used as inputs for the prediction model are the open value, high value, close value, and adjusted closing value, and the quantity bought and the sold within a given period of time are fed into the model. This enables the model to easily compare the given data by the users and automatically make the future predictions. So long short-term memory is a type of recurrent neural network for learning long-term dependencies. This methodology is commonly used for processing and predicting time series data, and this will guide users in predicting the stock prices. Then also the model takes in numeric as the data set of stock price prediction, including prices of different items over time. So the data is pre-processed to extract features that are necessary for this project for training. Then we also have data collection, where the collected data from various ways, for example through surveys and reports from traders. Then we also have data processing. So the obtained data is cleaned and processed by removing missing values and consistent data. We can validate the set of data which is got from training data, test the model's ability and performance. Then the suitable machines are then selected for optimal performance. As for the data is finally evaluated by feeding training, validation, and testing data into the model for better performance. Then in this project we are investigating the poor price estimation in the incoming market, which occurs due to lack of records. Then the significance of this project: as you all know, the tradition of predicting stock prices in the market is a difficult task for people because it's manual based, which can be at risk of error through manual prediction compared to automatic systems. So stock price prediction, especially while using machine learning, helps the user in discovering the future value of a given stock which is traded. The main significance of predicting stock prices is to gain significant profits. Then the scope: this model is aimed at solving challenges of overproduction, low production, and poor price estimation of the incoming market, which occur due to lack of records. For this case, the project involves use of previous market records, which are fed into the system that can compare the market trends and possibly determine the future prices according to the previous demands and supply records. Therefore, this model uses previous records to compare data and draw the market price ranges automatically. Then AI can be addressed in this project, whereby traders use artificial intelligence to analyze forecast markets with greater accuracy and trade firms efficiently with mitigate risks and provide higher returns. The proposed AI approach is long short-term memory, as we had earlier defined. So this one, it can process both individual data points and more complex nonlinear time series data and predict highly volatile price fluctuations. Then we have data description, the dataset description. So the dataset, we extracted some dataset called Banana Stock Prediction LSTM on Kaggle, which is a collection of historical stock price data for a company called Banana. The data is used to train and test a machine learning model based on long short-term memory, a type of recurrent neural network to predict future prices. The dataset may include features such as date, open price, high price, low price, close price, and volume traded. The purpose of the dataset is to provide a basis for training and evaluating a predictive model for stock prices using long short-term memory, and to encourage further research and experimentation in the field of stock price prediction. Then we also have data preparation and exploratory data analysis. This is how we cleaned the data, split it, how we showed the heat maps, the outlier plots, the confusion matrix, the correlation matrix, sorry. So the data can be cleaned by removing missing values, inconsistent data from the data set, irrelevant observations from the data set are also removed. The data was divided into training, testing, and validating data, where we have outlier plots, where outlier plots are the data points that differ from other observations or those which lie at a distance from the other data. They are mainly generated due to some experimental error in the statistical data analysis, and the dataset was divided into ratios of training, testing, and validation by 7:2:1. Then we have the heat map, which is a data visualization technique that shows magnitude of a phenomenon as color in 2 dimensions. It gives the dataset a nice visual. And this is the diagram of a heat map. Then we also have correlation matrix, which is a table containing correlation coefficients between variables. Each cell in the table represents a correlation between 2 variables. In other words, correlation matrix shows how features rate each other. So this is the correlation matrix of our model. Then we also have box plots. These are created to display the summary of the set of data values having properties like minimum, first quartile, median, and third quartile, and maximum. Then the AI model selection and optimization, where we have parameters and hyperparameters, where parameters are values that are learned by the model during the learning process, such as recurrent neural network, CNN, long short-term memory. Then hyperparameters are values that are set prior to training and control aspects of the training process, e.g. learning rate. This helps in controlling how quickly the model gets to the training process. Then AI model selection and accountability, where accountability refers to the responsibility of AI developers, users, and stakeholders to ensure that AI systems are developed, used, and regulated in a responsible and ethical manner. So AI accountability includes ensuring that AI systems are transparent, fair, and trustworthy, and they do not cause harm or lead unintended consequences. And we have explainable AI, which ensures that the model used for stock price prediction is transparent and that its decisions can be understood and justified. Then we have the results and discussion of this project. The model was trained and tested, which showed positive results, where it can predict future plays and as expected. So in stock price prediction project, the evaluation metrics are used to measure the performance of AI. The following are the used matrices. We have the accuracy, we have precision, we have recall. So accuracy is the ratio of correct predictions to the total number of predictions. Then precision, it's the ratio of correctly predicted positive observations to the total number of predictions marked as positives. Then we have the F1 score, which is a harmonic mean of precision and recall and provides a balance between two. Then we also have sensitivity. This is also known as a true positive rate and is the ratio of correctly predicted positive observations to the total number of actual positive observations. So these matrices can be calculated for each of the training, testing, and validating datasets in order to have an idea of how well the model is performing on different data. Then, as we conclude this project, an implementation of this model, stock forecasting, will be improved, thus helping users in planning for future trade plans accordingly. So you can visit the notebook of this project through this link on Kaggle. Also the dataset which we used, it is also on Kaggle. You can click on this link to get the dataset used. Then in this project we worked as a group of 2 and would like to appreciate our lecturer Dr. Garango Marvin, who guided us in writing down this term paper through his weekly lectures. As we were able to understand how to do the work, how to find the dataset, then endless discussions and consultations from colleagues and classmates enabled us to come up with the work. Thank you. And for more work, you can visit these links. They can guide you more.